Hello everyone, in this video I'll explain the flipping pancakes problem using the decrease and conquer strategy. So first of all, in the flipping pancake problem, I'm given a stack of pancakes, each of different sizes like shown in the start state, and I'm expected to sort them so that the largest pancake is the bottom and the smallest pancake is the top, like shown in the finished state. And I should only use one operation, which is the flip operation, which means to reverse the array from index 0 to index I. And I will show you how to do so in this example. But before doing the example, we should understand the base case in this problem. The base case is when I only have one pancake, then that pancake is already sorted. In this example, I have 4 pancakes. So in order to sort them, I will first divide the problem into sub-problems. So the first step will be to choose the largest element, the largest pancake, and in this stack. So the largest pancake will be number 4. So the first step will be to flip from pancake number 4 to the top of the stack, and this will be the result. And then I will flip all over the pancakes to get pancake number 4 to its right position. So now pancake number 4 is sorted and it's in its right position. So I will do the same steps in order to sort the remaining 3 pancakes. You can do the remaining steps with your own. And then here I will do the same, but on an array. So let's try to do the same steps on this array. So here I have an array of 7 elements. So first I will check if it's unsorted. If the array is unsorted, then the first step will be to choose the largest element in the array, which will be element number 7. And then I will flip from index 0 to index 4 in order to get 7 to the top of the array. And then here element 7 is the beginning of the array. And then I will flip all over the array in order to get element 7 to its right place. So now element 7 is in its right place and 7 is sorted. So the next step will be to find the largest element, but in the unsorted part of the array. So now 7 is sorted, so I'll ignore 7. So the largest element in the unsorted part is element number 6. So I will flip between index 0 and index 1. So so the result will be, so I flip between index 0 and index 1, so this will be the result. Now 6 is at the beginning, and then I will flip all over the elements in order to get 6 all over the unsorted part of the array to get 6 to its right place. Now 6 also sorted, and then I will do the same steps to the rest of the elements in order to sort the whole of all of the array. And now the pancake sorting algorithm implementation. I have 2 functions. The first function is pancake sort, and the second function is the flip function. The pancake sort function takes the array as an input. And here the outer loop iterates over the decreasing range of I from n to 1. This represents the unsorted part of the array. And in each iteration, it finds the maximum element in the unsorted part. And this if condition checks if the maximum index is not at the beginning of the unsorted part, it flips the array up to that index. And it then flips the array, it flips the entire unsorted part, bringing the maximum element to the correct position. And this flip function takes the array, which is the input array, and the end, which is the index of the last element in the sublist that needs to be flipped. And here we flip the elements until all of the elements are flipped. And to calculate the time complexity of the given code, let's analyze the operations performed in each part of the code. Here, the outer loops iterates from n to 1, where n is the length of the input array. The loop runs n times. Inside the outer loop, the index method is called to find the index of the maximum element in the unsorted part of the list. The index method has a time complexity of big O of n, since this operation is performed n times in the outer loop. And here, the time complexity for computing the summation for each pancake in the average case can be approximated as big O of n squared. And the time complexity for finding the maximum value of the array at each step can be is big O of n, and the overall time complexity will be the time complexity for summation for each pancake, which is big O of n squared, and time complexity for finding the maximum value in the array in each step, which will be big O of n. So the overall time complexity will be big O of n squared. And coming to the space complexity, since the pancake sort algorithm is an n-place sorting algorithm, it doesn't require any extra space. So the space complexity is big O of 1. And this is the end of our video. Thanks for watching.